All right, let's look at the homework 3.2, problem number 7. All right, so we want to find the absolute extrema of this given function g of x over the closed interval from -2 to 1. All right, let's do that. All right, so this turns out to be a pretty tricky problem. All right, we cannot apply the closed interval method because g of x is actually not continuous on this interval. And you can see that when x equals 0, which is unfortunately included in this interval, this function is undefined. All right, so we're going to have to do a little bit more work to find the absolute maximum and the absolute minimum. All right, so let's do that. All right, so first let's find the critical number. All right, I don't like the way it's written, so I'm going to write the 1 over x as x to the -1 power. All right, and then -2 over x squared as -2 x to the -2 power. All right, this way we can just use the power rule to take the derivative. All right, so if you take the derivative, so g prime of x is equal to, all right, put the negative in front and then subtract the 1 from -1, so it's a -2 power. Put the -2 in front, so -2 was already there, so it's a -2 times -2 is +4 x to the, subtract 1 from the power, so it's a -3 power. All right, then I'm going to write it as a fractional form, so this is going to be equal to, all right, this is the same thing as negative 1 over x squared. All right, and then plus second term is 4 is on top over, all right, negative x cubed, so it's going to be x to the third on the bottom. All right, so to find a common denominator, I'm going to, which is x cubed, so I'm going to multiply top and bottom by x so that we have a common denominator. So this is going to be, common denominator is x cubed, right? And then here you have a negative x from here, so negative x, I'm going to put it right here, and plus 4, so I'll put 4 here. Right, so let's find the critical number. So we set that equal to 0, and which means that see that x has to be 4. So we set 4 minus x equals 0, which means that x is 4. Right. So this is a critical number. But here, if you look at it, critical number 4 is not even on this interval. So we're not going to consider this one. Right, so let's do a number line. So number line is going to be here. There's not much we can do except that here we know that the function is not defined at 0. Maybe we should indicate that. So here's a 0, right? And also the interval is going from -2 to 1. So I'm going to put the -2 right at this end, and I'm probably put 1. It doesn't have to be the right scale. All right, then we're going to look at the derivative value, so g prime, right? So let's do a sample number between well, sorry, I didn't put the negative sign, so it's a -2, right? So this is going to be x equals -1, and between 0 and 1 I'll try x equals 1/2. All right, so if you type in, plug in x equals -1, right? So here, all right, -1, so that's going to be -1 cubed, so that's negative. All right, 4 minus -1 is 5, so this is going to be positive. All right, positive divided by negative is negative. All right, then if you try x equals 1/2, all right, so 1/2 cubed is definitely positive. Right, 4 minus 1/2 is positive, so positive over positive is positive. Right, so what happens is that the graph-wise original function g is going to be decreasing before 0 and increasing after 0. Right, it's very tricky. So we want to do, it's very tempting to say, oh, it's decreasing and increasing. So you're looking at the bottom of the valley. But at 0, this is not a critical number. It's actually, function is not defined at 0. So what happens is you're going to have a sort of a vertical asymptote which kind of shoots down to negative infinity, and it's coming from a negative infinity on this side too. All right, so but it's worth evaluating f of the endpoint. So let's try f of negative 2. All right, so which is going to be equal to, plug it in, 1 over negative 2 minus 2 over negative 2 squared, so it's going to be 4, right? So this is going to be negative 1/2 minus negative 1/2, so it's going to be negative 1, right? And if you plug in x equals 1, which is the other endpoint, and you're going to get, let's see, 1 over 1 minus 2 over 1, which is going to give you negative 1, right? So you can see that the highest point actually happens at negative 2 and the positive 1, because it's going to, so this is going to be the highest point. So this is the absolute maximum at this point, and then there's a tie because it gives you the same number. So this is also an absolute maximum, and we know that those are the maximum because here, if you move over here, the graph is dipping down, so it's not going to beat this guy. Same thing, if you move to the right, the graph is going down, so this is going to be the highest point. So we have a tie, so we have an absolute maximum, there are two of them, and then absolute minimum does not exist since this guy shoots down to negative infinity. So this is going to be a no absolute minimum, right? So let's type it in. All right, we got, so absolute maximum happens at negative 2 comma negative 1, and also positive 1 comma negative 1, and then there's no absolute minimum, so it's going to be does not exist. All right, let's check the answer. All right, I came back, and it looks like we got this one correctly. All right, that's it. I hope that this was clear. Actually, I haven't done the graphing utility, so maybe I should open it up here. All right, so I already actually drew this picture. All right, so it looks like this. You can see that the highest point is going to happen right at negative 2 and 1 here. It's going to be a tie. Then you can see that it's shooting down to negative infinity, so there's no absolute minimum. All right, that's it. I hope that this was clear.